in our syllabus, the topic is Bayes classification, Bayes classification for text data. For text data is on syllabus, but before that you have to understand what is Bayes classification, how it works. So as you know that Bayesian classification method is based on Bayes theorem. Okay. So what is the difference between, and it has been developed by Thomas Bayes. Bayes theorem is developed by Thomas Bayes, that you know, long back. But Bayes classifier assumes that effect of an attribute, because we are discussing about this classification on text data or normal data set. So there it assumes that the effect of an attribute value on a given class is independent of the values of the other attributes. What is what this Bayes? So you can see that first it is Bayes theorem. But when it is incorporated in ML and in other subjects like this web mining and all, they are calling it Bayes. Name slightly changed. Okay. So Bayes, what is the significance of this naive word? This is used as a classifier. This classifiers assume that the interesting point, that the effect of an attribute value on a given class is independent of the values of the other attributes. It's a big statement actually, and this is one of the reasons why Bayes classifier somewhat not that successful. Okay, still that Bayes classifier is used. What it tries to say that if I have a data set, these are my attribute, let's say, and this is my decision attribute, as I always says. These are all entries x1, x2, x3, x4 instances. So this is decision attribute, that means let's say last column. It says that effect on an attribute value on a given class, let's say this is the class, positive class or negative class, let's say binary classification, is independent of the value of the other attribute. That means it is not getting influenced by A1, A3, A4. If we start getting influenced by this attribute, then you will get very wrong results. So this is the first thing. Apart from that, Bayes theorem is named after Thomas Bayes, is a English mathematician. Here one concept is called hypothesis. Concept is there. What is hypothesis? Hypothesis. So let's say age be some hypothesis. Age be some hypothesis. Hypothesis means the thing that we are going to predict. That is called hypothesis. Okay. Such as the data tuple X. Data tuple X. Let's say X is the data tuple. Belong to a specified class C. Okay. Based on this Bayesian classifier actually developed Bayes theorem. So in classification problem, we want to determine probability. Very careful. Probability of the hypothesis that H. What is the probability of this hypothesis that this hypothesis will occur? Given that class, given that the tuple X, that means this tuple X, how much it will be, which class it will belong, whether it will belong to class positive class or negative class. That is the given thing. And this it is going to predict. Okay. So this is called hypothesis. H is called hypothesis. So hypothesis H holds given the evidence or observed data. This hypothesis H holds given the event X, that means event X occurs. That means this entry happens, let's say in the test data, unknown entry happens X1. Whether this X1 will belong to negative class or positive class, that it is going to say. Okay. So this is the main thing of Bayesian classification. So what do you think? This is conditional probability or prior probability? It's a conditional probability. So this is called conditional probability. So now onwards, we will be knowing this conditional probability and prior probability. If anyone asks you, will be immediately able to say this is condition, because this probability hypothesis is conditioned upon the X, is X. So this is conditional probability. But if I say what is the probability of PH, this is called prior probability. That means it's not depending on any of the event. So this is prior probability, this is conditional probability. Now, okay. So finally, this conditional probability also called posterior probability. Posterior. So many places you will find textbook posterior probability. Immediately you have to understand this is a conditional probability. Okay. So this is Bayes theorem, students. Bayes theorem. Based on this, Bayes theorem has been developed, which is used in ML and web binding subjects like that we are dealing with, and any other AI related subjects, because we have slightly changed it. Okay. Bayes. Posterior probability you understood, prior probability you understood, everything you understood. Okay. Now let us, and then finally Bayes theorem, how it will look like. Finally Bayes theorem will be looking like this. Bayes theorem will be look like, so Bayes theorem is useful in that it provides a way of calculating the posterior probability. P H X, this we have to calculate. So now if you write, and then this, now finally Bayes theorem will be looking like this. P, what is the probability of this hypothesis given the tuple X, will be expressed as, this is the final Bayes theorem formula, P X given H into PH divided by PX. So this is the final formula that has been incorporated in Bayes classifier. Okay, so this is the formula of Bayes theorem. So which is a combination of posterior probability and prior probability. So if I ask you which is posterior probability, you will say, sir, this is posterior probability or conditional probability, and these two are the prior probability. Okay, finally this is the situation. Okay. Now, this is Bayes theorem. Now let us see how Bayes behaving. Bayes theorem is a huge thing. Okay, Bayes theorem itself, Bayesian classification itself is a subject. So Bayes classification. Some points I'll mention. If you want to write, you can write it. In Bayes classifier works like this. Point number 1. Let's say D is the data set, capital D is a training data set. First we will see how it behaves with the normal data, then we will go to the text data. So be a training data set and their associated class level. So instances x can be represented as x1, x2 up to xn. Okay, and attributes can be represented as a1, a2, a3 up to an. Point number 2. Let's say we have m classes. If it is a binary classifier, value of m will be 2. If it is not a binary classifier, let's say m classes means I have classes C1, C2, C3 up to Cn. That means it is also okay with the multi-class classification. Okay. Now, interesting point. Given a tuple x, the classifier will predict x belongs to class having x belongs to class having highest posterior probability. That tuple x belongs to class Ci or Cj. Ci, not Cj. If and only if probability of Ci given x is greater than probability of Cj given x for 1 less than j less than m. Meaning is simple, and j not equal to I. Okay, so whichever class probability, let's say for a particular tuple x1, there are 3 positive class being predicted, and for this x1, 1 negative class being predicted. That means the probability of C, this is higher than this. That means Ci class, that means positive class will be selected. That is the meaning. Okay, so we have to maximize this. So further I can write it. Thus we maximize Ci given x. The class Ci for which Ci given x is maximized is called maximum posterior hypothesis. Is called maximum posterior hypothesis. And finally, this Bayes theorem will be slightly changed. P, instead of that hypothesis, now we are dealing with class. Let's say Ci. What is the probability of class Ci? Let's say positive class or negative class, whatever it is. Given instances tuple x, that you can write. It will just change it. Px given Ci into Pci divided by Px is the final formula. Now, here are some interesting points. First interesting point is, you understood this. Interesting point is that this Px, this denominator is constant for all classes. This denominator is constant because it is denominator, it is constant for all classes. Okay. And that means if it is constant for all classes, you can ignore it. Constant means it's paying no contribution to the overall probability of this, so we can just simply ignore it. So now we will be interested in this part, which is nothing but Pxci into Pci. Okay. If you look at this component, this is the multiplication of conditional probability and prior probability. Okay. Now here this probability, this component PCI, so I can write it if class prior probabilities are not known. That means earlier, initially when you start with the data set T, you do not know how many tuples are actually positive class, how many are negative class. That means everybody has equal participation, could be equal participation. That is what you will be assuming. Okay, if it is the case, then everybody has the equal likely chance that everybody might appear. Either it can be positive class or negative class. That means the probability before the execution start, PC1 equal to probability of PC2, total number of classes, PC2, this is C2, PC3, all are same. In fact, PCM, all are having equal chances of appearing. That means they are called equally likely. Okay. So in this case, if they are equally likely initially, so we can ignore this part also. That means from this component, we can also ignore this part. Okay. So we are left with this fellow, P of X given Ci, which is a conditional probability, and for a particular instance you have to find which class probability is maximum. That means you have to maximize this guy. Okay. Maximum value of this component. This is equally likely chance, we are ignoring. This guy is same for all because it's a denominator, we are ignoring this. We are left with this fellow, and we have to maximize this. Whichever class for a particular instance maximum value comes, that will belong to that class. That particular instance will belong to, let's say, positive and negative, both classes are there. For positive class, if it is for x1, positive class probability is 0.9, negative class probability is 0.2, we will choose positive class. That means x will go to positive class, it will classify as positive class. This is the thing that we have to maximize. Now this has to be true for all attributes. So finally it will look like this. So finally, so given data set with many attributes, it would be extremely computationally expensive to compute PXCI. This is also a true thing. That means data set we have many attributes. Because data set is like this: A1, A2, A3, A4, A5. Let's say this is decision attribute class attribute. So we have many attributes. So computationally, obviously, it will be exhaustive to compute Px given Ci. To reduce the computation to evaluate PXCI, the naive assumption of class condition independence is made. This presumes that the attribute values are conditionally independent of another. That means that thing that I was earlier telling you. Whether A is influencing B, A2, A1 is influencing A2, then these two guys create problem. A1, A2 individually influencing A3, because we don't know the values and attributes name. What are the attributes? We do not know. A1, A2, A3 can influence A4. See, if everyone started influencing other, then obviously decision attribute will be also influenced. So this is independent. So independently we will calculate. We are not considering any other things. So finally, the formula will be, independent relationship will be Px given Ci is equal to pi. We are considering all attributes, but assuming that they are not influencing each other, k equal to 1 to n Pxk given Ci. And then finally it will be this this notation is for pi, means multiplication. Okay, always remember pi is multiplication. So P x1 P1 Ci into P x2 into, let's say this is Ci. This is also Ci for particular class. Ci means let's say it's a positive, means positive class. All instances positive class you have to calculate. Okay, then P x3 Ci, like that you have to keep calculating P xn Ci. Okay, this is all you have to calculate. So now this is the final formula. We can easily estimate the probability of this. This is possible to calculate. This is possible to calculate. This is possible to calculate. This is also possible to calculate. Okay. So this is the situation. Now here is one catch is there. That is, if AI, now the data set that we will be dealing with here is our book. So you can see this data set we will be considering here. This is a categorical data. Okay, it's a categorical data. That means all the inputs are youth. So this is a data set which says that all electronics is a shop. Let us assume this is a shop. Okay, and here these are the customer detail. And in this detail, we have 1, 2, 3, 4, 5, 6. That means attributes are age, income, student, credit rating, and then finally decision attribute is class. So these are all categorical data. In this categorical data, age has been divided into 3 parts. That means either that person will be youth, young, middle age, and senior. Based on that, what will be the income of it, and what will be the credit rating also given. And finally, based on these all things, so this part of the attribute is participating attribute, and this is the decision attribute. That means whether that person will purchase the computer or not. Okay, whether he will purchase the computer. So this is binary classification, or either yes or no. Based on this detail, whether the person will purchase a computer or not. Okay, buy computer, yes or no. These 2 classes, binary classification. Income, student, all this. So these are the participating attribute. This is decision attribute. So this is a data set that we will be dealing with. No problem. In this data set, if it is numerical, real data, then this calculation won't be applicable if it is real data. Okay, so in that all electronics data set, if datas are real data means values, then continuous values, then you have to do more work. You need to do more work. Okay, you need to do more work, and that method is called Gaussian distribution. Gaussian distribution. What is Gaussian distribution? Any idea? Very simple strategy, Gaussian distribution. Gaussian distribution is like this. If data set is like this, is Gaussian distribution. As simple as that. It's a, what do you call it? There is another name of it. Anyway, I forgot that name. So this is Gaussian distribution. The Gaussian distribution method you have to use. This is graph. So that Gaussian distribution comes under like G, mu, sigma. Mu is the mean, sigma is the standard deviation, and separate formula comes for that. I will show you in the next class. But if this is a real data, all electronics, then you have to apply this Gaussian distribution method, and then only you have to do. Okay, but our data is not that, so we can skip that. So now let us go to the data set again, or let us come to the point. What is the given problem? Given problem is, this is my unknown tuple. Okay, I have discussed everything. Don't say no. So this is the, I'll just simply again copy the data set. Have X. So predicting a class level using naive Bayes classification, we used to predict the class level of a tuple using naive Bayesian classification given the same training data that has been given, the table. The data tuples are described by the attributes age, income, student, and this is the data tuple. Age, income, student, credit rating. This is the final class that you have to predict. And the class level attribute by computer has 2 distinct values, that is yes or no. That means binary classification you have to do. Let C1 correspond to the class by computer, yes, and C2 correspond to the class by computer, no. The tuple we used to classify is this. That means our intention is to classify what is our unknown tuple, students. This is an unknown tuple. Using naive Bayes classification, what will be this? If this is X, age is given youth, income is given medium, student has given yes, credit rating is fair, whether he will purchase a computer or no. He won't purchase. That is the test data set, you can call it. Unknown data set is given. So using this naive Bayes classification you have to do. So first what you have to do, you have to compute the prior probability. This is the prior probability negative class, prior probability for the positive class. So very simple. Prior probability for the negative class, you see how many positive instances are there. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 9. 9 instances. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total there are 14 instances. Okay. So 9 by 14 is a prior probability class for by computer yes, which comes around 0.643. Similarly for the no class, how many instances? 1, 2, 3, 4, 5. 5 by 14 is the negative prior probability for both the class, yes class and negative class. That means positive and negative both class prior probability is this 0.6 and 0.35. Now you have to calculate the given thing. Given thing is age equal to youth has been given. So as we are decided that it is like, if you see the formula here, it is not affecting the other things we are ignoring. That means whenever we are saying something, we are just multiplying it, and other things we are ignoring. Okay, computational hazards will be there, so that other influence you are ignoring. And then here you can see age equal to youth by computer yes. That means how many instances are there where age equal to youth and by computer yes is there. So by computer yes, total 9 instances, age equal to youth, and by computer yes, by computer also yes. How many instances are there? Positive 1. This is no. This is age equal to youth. This is age equal to youth 1 instances, and age equal to youth 2 instances. That means 2 instances are such which are age equal to also youth, by computer also yes, age equal to youth, by computer yes. So 2 by 9. 2 by 9 is the probability of age given by computer yes. Then similarly for by computer youth, age equal to youth, by computer no. Total 5 instances are there, which will be like youth equal to no 1. This is 1, 2, 3. Total how many instances? 3 by 5, 0.60. Similarly, next attribute is given as input equal to medium, income equal to medium. So income equal to medium, how many positive instances with income equal to medium? How many negative instances are that you have to calculate, which comes around. For positive instance it is 4 by 9, 0.444. For negative instance 2 by 5, 0.400. Correct, students? And then for second instance, whether he is student or not, if you see this one, second, students equal to negative, students equal to not negative. So that kind of instances are there. Yes, 6 by 9, no. Students yes, 1 by 5, students no. Student yes, yes. Students yes, no. That is 1 by 5, 0.20. Credit rating also you have to do similarly, 6 by 9. Credit rating fair, no, 2 by 5. Totally all, so given these attributes, age equal to youth, income equal to medium, student equal to yes, everything you have to calculate with respect to the class yes and no. Now simply if you write whether x equal to by computer yes, you have to see multiplication of all these attributes. Age equal to youth into age equal to income, age equal to students, age equal to credit rating. So if you multiply age equal to x by computer yes, p equal to age equal to youth by computer yes, yes, all positive classes if you calculate. So from here you can say 0.22, 0.44, 0.67 and then 0.67. So all you multiply together, it is coming around 0.04. And similarly for class no, you have to calculate this. No class means what? This first one is this one. Age equal to youth by computer no, which is 0.60. Next no class is this one. Income equal to medium by computer no, 0.40. Like that, if you multiply 0.60, 0.40, 0.20, this comes around this. So age equal to yes, x by computer yes, total considering all attribute probability is coming around 0.04, and by computer no, unknown customer probability is coming around 0.09. Now go to the formula. What is the formula says? Formula says that this is the Bayesian formula. This is the formula. So ultimately we have come across this. We have ignored this part. We are left with this probability, and this also their prior probability. Individually what is, so that means this component into this component play the final role. So here you see. So finally what is the situation? By computer yes has come this 0.44, and what is the probability of by computer yes, prior probability, which is 0.643. We calculated at the beginning itself. Why are we calculating here? Prior probability of yes, prior probability of no. The prior probability of yes, this is there, and conditional probability of this is there. Yes multiplied, and this is this much. For no also prior probability you calculated this is this much. Which one is more? This one is more. So the given tuple, unknown tuple, which is x equal to 8, this will actually by the computer because the probability is huge. Okay. So this is Bayesian classification using categorical data. For numerical data, we have to follow Gaussian distribution. That I will show you in the next class.